guys, it's Mrs. Applegarth. I'm back doing Chapter 1, Section 7. This is midpoint and distance in the coordinate plane. So we were talking about line segments before. Now we're going to throw those line segments onto a graph and finding halfway between the endpoints, and we're going to find the distance or how long that line is going to be. Okay, so imagine we have a point anywhere x or y on the x-axis. We're just going to call it A. So the x coordinate and the y coordinate are inconsequential at this time because we're just talking in generals. And then we have a b coordinate also living on our graph somewhere, anywhere on our graph. They are connected by a line. Boop. And we're going to find two different things. We're going to find the midpoint, which I actually really love the midpoint. So on your paper, please write midpoint. Above or next to midpoint, write A, x1, y1, and B, x2, y2. Please note that these little numbers, it's called a subscript, and it just means a different x than this one. So we just use these little subscripts to say one x coordinate here and then a different x coordinate here. So the ones and twos aren't mathematical at all. They're just a different way to describe point A and point B. Okay, so you guys have written down, let me highlight so you. So section 1.7, midpoint and distance in the coordinate plane. Write down A is x1, y1, and B is x2, y2. And then write the word midpoint, because we're going to throw down the midpoint formula. Yay! I love a good formula. Don't even get me started. Okay, so we are talking a point here. So a point has an x value and a y value when we're talking points on the coordinate plane. So our x value is going to be the average of these x's. So it's going to be your first x plus your second x divided by 2. The y value for your point is going to be the average of the y's. It's going to be y1 plus y2 divided by 2. So all together, it looks, your answer is always going to be a point. So your answer is going to have an x value, comma, a y value, and be in parentheses. So as you look back, or if I ask you to do this on a Google form, it goes parenthesis, your x coordinate, comma, your y coordinate, these are numbers, and then close parenthesis. So when we're asking for the midpoint, you're actually getting a coordinate. Okay. And I do want you to write that down. So x1 plus x2 divided by 2 and y1 plus y2 divided by 2. It's got to have a comma in between and be hugged by these little parenthesis arms. All right. That's the midpoint formula. We're going to take a moment and also do the distance formula. So please write down, oh, I switched out of highlighter mode too quick. Please write down distance. So if I was going to take, we can actually find the length of this line, and we don't even have to get a ruler. Oh. So we're going to, I'm going to show you mathematically how to get the distance. All right, so to write the formula out, we need a big square root because it's going to hold a lot of things in the middle. We got a set of parentheses, so the first thing we're going to do is take our second x coordinate minus our first x coordinate, and we're going to square it. So you do this in your calculator, and then you square it, and then write this number down. Then we're going to take our second y coordinate minus our first y coordinate, and we're going to square that. We're going to do this in our calculator and write the number down. Then we're going to add the x coordinate subtracted squared with the y coordinate subtracted squared. Write that answer down. Then we're going to take the square root. Okay, I do need you guys to have this formula written down. Remember, all of our assessments are open notes, so it's important to take good notes. And I'm going to be expecting you to turn it in with this week's assignment. Okay, so let's see. Let's practice the midpoint and the endpoint. I'm going to take the formula with me through the power of through the power of technology. I'm just going to drag this formula around. And until you have them memorized, I need you to write down the formula before you use it every time. Okay, so in example 1, we have endpoints -2 and 3 and 5 and -2. So we're going to find the midpoint and the distance. So I'm going to also drag this formula with me wherever I go. All right, so first piece of bookkeeping, I go ahead and I label my x1 and my y1 and my x2 and my y2. The very first one that comes up is going to be x1. The very first y that comes up is going to be y1. This guy is going to be x2 because he's on the second point, and this guy is going to be y2. Okay, so we label that. I do want you to write that down so that when you come back to this later, you know where all these numbers are coming from. Okay, so have this labeled, and it's okay to have just the formulas because we can backtrack it to our notes. Okay, so now let's do some substitution. Let's plug in the numbers and start pushing that formula. Okay, so x1 is -2. x2 is 5. We're going to add those together and divide by 2. -2 plus 5, and you guys, I do like you using a calculator to make sure you get the right answer, because the way some of you guys aren't really good at positive and negative numbers and how they combine together. So I want to make sure you get the right answer, and then there's no reason not to have this done correctly. Okay, so this guy, -2 plus 5, is 3, and 3 divided by 2 is 1.5. So my x coordinate for my midpoint, this guy here, is 1.5. Now we're working y's. y1 is 3. y2 is -2. And we're going to divide that by 2. So again, 3 plus -2 is 1. 1 divided by 2 is 0.5. So my answer to the midpoint is 1.5, comma, 0.5. And when I ask you guys to show your work, this is what I mean. I will want the numbers filled out and the division shown, as well as the answer. Okay, let's do that, something similar with our distance. So this is definitely a separate problem. This is the midpoint. Now we're going to do distance. So we're going to take x2, which is this 5 right here, and the x1, which is -2. We're going to go 5 minus -2 squared. I'm going to fill in all the little numbers first before I start simplifying them. Y2 is -2. And Y1 is 3. Okay, again, I'm going to go ahead and don't forget the square root here. I'm going to go ahead and grab my calculator. We're going to go inside the parentheses first and clear up parentheses because order of operations says, please excuse my dear Aunt Sally. That's what I get for so it's parentheses, exponents, multiply, divide, add, or subtract. So we're going to do 5 minus -2, and we get 7. So we're going to rewrite this. And I know some of you guys may find this rewriting process tedious, but it is really, really important because it means that you get the problem correct. So then we have -2 minus 3. -5. Okay, then we take the square root. 7 times 7 is 49. -5 times -5 is 25. 49 plus 25 is 74. And 74 isn't a perfect square, so we're going to get an approximate value. When we do approximate, we get 2 squiggly lines, and because it's not exactly equal, so it doesn't get to stay straight. Okay, so if you want, oh no, I have a square root here, so right, square root. So we get 8.60 is our distance. Okay, make sure, I want you guys to write that down, so I'm highlighting it. Okay, we're going to try that process again. If the midpoint, oh, this is a little trickster's ones, they're going to give us the midpoint. So they're giving us the answer first. And one endpoint is -1, 7. So we're going to call this x1, y1. Find the coordinates of the other point. So remember, I'm going to pull that. Let me pull the formula down. So I know that this and this are the same. This is equal to 2 because it says find the midpoint. And then this is 4. So I have two separate equations here. I have x1 plus x2 divided by 2 is equal to 2. And I have y1 plus y2 divided by 2 is equal to 4. So they're going to make you work backwards to find the other endpoint. So this is the second way you're going to see endpoint. So we know that -1 is x1. We do not know what x2 is. And remember this little 2 here, he is not actually a part of, he's not a number. Well, he's technically a number, but he just describes that it's the second x in our 2 points that we're referring to. So we don't use him as a number. We just use him to say second x. All right, so we're going to solve this little equation. So what we have to do first is we got to get rid of this divided by 2. Timesing by 2 will always be your second step after you substitute in your number. So 2 divided by 2 is 1, and I'm just left with -1 plus x2 equals 4. The next thing I'm going to do is I'm going to add 1 to both sides. I need a little bit more room to do it, sorry. So add 1 to both sides. Boop. And x2 equals 5. I'm going to hold on to that. I'm going to partner him up with his y coordinate over here in just a second. Okay, so we're going to take where the y1 is on this equation, and we're going to put in 7. And when we do that, the next step is the same as the next step here, and it will always be the times 2. 2 divided by 2 is 1, so we're just left with 7 plus y2 equals 8, and we're going to subtract 7 from both sides. Okay. Now we're going to squish them together because they've been separated for so long. And we're going to say that the end point is 5, 1. All right, let's highlight everything you guys need. I need this filled out. We need to show that we substituted and divided by 2. We need to show that we added 1 to both sides. And we need to know that x2 is equal to 5. I do need this formula written out that it equals 4. I need 7 substituted in. And I need to show that you multiplied by 2. Then I need the equation 7 plus y2 equals 8. And you need to show me u minus 7 from both sides. And finally, I do need the endpoint written out as 5, 1. All right, we're going to use the distance formula for example 3. And just for fun, I'm going to grab my copy of the distance formula and pull it down. I got stuck in traffic there. Okay. So step number 1, get the formula out. And please rewrite it as many times as you need to until you have it memorized. So yes, I want you to write this down. Is the answer to that question. Okay, so the first thing I want to do is label. So the first item, the first number that comes across our path is x1. The second one is y1. The third one is y2. And the fourth one is, sorry, x2. Fourth one is y2. So I do need you guys to write down the coordinate that we're looking at and that it is distance that we're trying to find. All right, we're going to plug those in. So x2 is 4. X1 is -7. Y2 is -3. Y1 is 5. We got to make sure we square root the end result. Okay, so now we're going to grab our calculators. We're going to go 4 minus -7. It's 11. If it doesn't have a negative on it, you don't have to put the parentheses. But this next one, you're going to have to put parentheses because it is negative. -3 minus 5. It's -8. Again, it's square rooted. I love a good perfect square. So 11 squared is the same as 11 times 11, or if you change it to scientific view, there is a squared button here. So you can go 11 squared, so 121. -8 squared, if you're going to put this in the calculator, it does need parentheses. Parenthesis, -8, and parenthesis, then squared. If you don't put the -8 in parentheses, your calculator is going to think you want to square it first and then attach the negative on it. So make sure you have it in parentheses. Okay, 121 plus 64 is 185. And we want the square root of that. 185 is not a perfect square, so we're just going to straight up take the square root and round to the nearest hundredth. So we change this to the approximately, and 13.60. All right. And we're going to highlight what you guys need to write down, which is all this work. I'm continuing the tradition of showing your work. That will always be a part of this class. If there's work to be shown, I want to see it. Okay, a 20-foot ladder is resting against the side of a house. So let's get our house out. Okay, let's try to get a pen. All right, so let's put our house down. Okay, 20-foot ladder is resting from here to here against the side of a house. So that the base is 8 feet away. So from here to here is 8 feet. From here to here is 20 feet. How far up the house is the ladder reaching? Draw a diagram. All right, to solve this, we're going to engage in a little Pythagorean theorem. Which is a squared plus b squared equals c squared. So I have a little triangle situation happening here. If you redraw it without the house, this is 20 feet, this is a right angle, and this is 8 feet. So essentially, this is A, this is B, and this is C. Make that a better B. There we go. So we are going to use the Pythagorean Theorem and plug in the numbers. So A is 8 feet. B we don't know. And C is 20 feet. If you haven't seen the Pythagorean Theorem, it is okay. Just write it down for now, and we will definitely be working with that more so that you guys get comfortable. 8 squared is 64. B squared stays the same because it's not a number. I can't just type them in my calculator, unfortunately. 20 squared is 400. And I'm solving for B because how far up the house does the ladder reach? So I'm going to subtract. So you look, okay, I want to get B by itself. I got to get rid of 64. It is a positive 64. So to get B by itself, I'm going to minus 64. We get 336. And then to find what B is, so this is a squared. The opposite of square is square root. So we are going to take the square root of both sides. It's going to cancel, the square root and the square are going to cancel out. And I don't think 336 is a perfect square. But we'll take the square root. No, it's not. So we got to give a wavy line. And it's 18.33. So give it a wavy line because it's not going to be equal. We're rounding. And that is feet. All right, my friends, for the secret word, I want the secret word to be, it's 2, midpoint and distance. Midpoint and distance, that's the secret word. If you missed that, make sure you add that in. I do want you to write down how we use the Pythagorean theorem, write down all this work, and then I do need, let's go, your best version of this picture. I know it's going to be hard to top my version of it, but do your best. All right, and that's it for Tuesday's session.